So today I was going to look at doing a practice exam with you guys out of your P book. This is for geometry, and this is the first test in that book. Probably won't do all the questions on one video, but we'll break it up, starting with question 1. So, the location and distance between three towns, Aville, Bville, and Cville, are shown. Find the distance between Bville and Cville. So we've got a lovely right angle triangle here. And again, if you've watched the video on when to use sine, cosine, tangent, or Pythagoras, you would recognize from this video that we're dealing with side, side, and we want to know a side. So all sides, we're looking at Pythagoras. This is also a short side. So we are going to go 64 squared minus 36 squared square rooted. That will give us the length of x that we're looking for, and this is 52.9 kilometers when you plug it into your calculator. So again, the long side is always the one opposite the right angle triangle, or the right angle, and so these are the two short sides. You use a minus sign when you're doing a short side. Alright, question B. Find the bearing from Aville to Bville. So in this particular question, we need to remember what bearings are. Bearings are always measured from the north, and they are written as three numbers, such as 003 degrees or 132 degrees. So let's go ahead and look on the diagram and see exactly what it is that they're looking for. I'm going to take this part off. We'll come on here with a blue marker. So north is up. You can get that from the little compass here. And they want to know the bearing to go from A to B. So they want to know this angle here, starting from north and going to the direction that you're looking for. So they need that angle there. So what information do we have? We've got lots of information here we can use. So we have a right angle triangle. We've got the information for all three sides, and we can use some of that information to possibly find an angle. So what happens if we look for this angle inside of here? Let's call it A. Well, this is the adjacent. This is the hypotenuse of the triangle. And since we're using an angle, or trying to find an angle, we're going to use our trig functions like sine, cosine, and tangent. So in this case, we have A and H, which gives us Ques. And we want to find the angle, which is the C, the cosine bit. So we need A divided by H. Now remember, if you've watched those videos on sine and sine inverse, when to use them, we're going to use the inverse function because we're looking for the angle. So use inverse function. So we're going to use cos inverse in this case. And we feed cos inverse a side-side sandwich, and in this case it needs to be the adjacent over the hypotenuse. And this comes from, again, our little helper triangle here, Ques. Looking for the angle, we need A divided by H. So cos inverse of A over H is going to be 36 over 64. If we plug that into our calculator, we get 55.8 degrees. Now that, remember, gives us this angle here, 55.8 degrees. So how big is the angle that we're actually looking for, our bearing? Well, you might recognize that this might be angles on a straight line. And so we know that 55.8 is A, and we can use 180 minus 55.8 to figure out what the bearing is. So to find our angle, 180 minus 55.8 gives us 124.2 degrees. Now catch yourself here. Bearings can only have 3 numbers, always have something like 1, 2, 3 degrees, or 0, 4, 3 degrees. So we need to round and get rid of that decimal. So our final answer would be 1, 2, 4 degrees as your bearing. Okay. Going on to number C. A building in Cville is 24 meters tall. A person standing 50 meters from the base of the building. Find the angle of elevation, the shaded area. It's hard to see that this is shaded, but they're looking for this. And elevation also means how far up you'd have to look, for instance. So from the horizontal, or from the ground, how far up do you have to look? That's your angle of elevation. So we do have a right angle triangle here, and we're looking for an angle. So again, we need to use our cosine, sine, and tangent because we have angle or want to find angle information. This happens to be the adjacent side because it's touching the angle that we're looking for. And this happens to be the opposite side because it's opposite the angle that we're looking for. So we're going to be using tangent and using our little triangle, that's TOA. And again here we're looking for an angle, so we need to use the inverse function. So we're going to use tan inverse, and we need to feed it a side-side sandwich of opposite over adjacent, and make sure you use your brackets. So tan inverse of 24 divided by 50, and we will get, plugging it into the calculator, 25.6 degrees. And that is our angle of elevation, if we call that y, the angle that we're looking for. Again, if you're confused on when to use tangent or tangent inverse, you can check out the previous video on when to use regular and inverse functions. Okay, I think I'll stop the video here and start another one for page 2. No, we'll just carry on. I'll finish question 1. Alright, 2 buildings in Cville are separated by a walkway. One building is 24 meters tall and the other is 19. What is the length of the cable between the two? Okay, so remember we're doing geometry here, and it's very likely that we're looking for a right angle triangle, and voila, look at that, they've given it to us. So we want to know this distance here, the cable strung between the buildings. They've given us an angle, and since we have information on the angle, or we're looking for an angle, we know we're going to be using sine, cosine, or tangent. And what other information have they given us? We don't know the distance between, but can we figure out this height here? We can. That's 24 minus 19. We know that this height is 19 meters. And that height there is full 24, so the difference between gives us the information. So we're actually dealing with a right angle triangle that looks like this, 8 degrees, a length of 5, and we're looking for x. So we have the opposite and the hypotenuse in this case, meaning we're going to use sine. So using we're looking for the hypotenuse. That means that we're going to have x is equal to the opposite, 5, divided by sine. And remember, you have to feed sine an angle. You have to give it something. So sine of the angle. And the order matters. You need to do 5 divided by sine 8, not sine 8 divided by 5. And if we do this, we get 35.9 meters. So that's the length of the cable between the 2 towers. Question 3. A helicopter leaves Aville on a sightseeing flight and flies on a bearing of 205 degrees for 48 kilometers until reaching point B. It then heads, well, let's start on our diagram because we're going to need it. So with a bearing, remember, always start from north. So here's where we're starting at point A, and there's north. and I know that I have a bearing of 205 degrees. Now 205 degrees is more than a straight line, but less than 3/4 of a turn, so I'm going to guess probably about in here, meaning that that's 208 degrees. And we travel for 48 kilometers until we reach point B. It then heads directly east. Remember, never eat soggy Weet Bix. So straight east, and it heads straight east for 64 kilometers until it reaches point C. And then from point C, it heads back up to point A. Alright, by the most direct route, and that basically just means a straight line. So calculate the course, or the bearing, the pilot must head, and the distance he must travel to get back to the airport from C. Draw a diagram in the space provided if you wish. Well, it is very helpful to have that diagram. So let's identify here. Calculate the bearing the pilot must head on. So remember, bearings are always from the north, and this is from C. So we're going to start at C on the north, and we go clockwise from north. So I need to know that angle. That is the angle that we're looking for. That's our bearing. Okay, and I want to know the distance that he travels from C back to A, so that's x. Right. So, starting with the information we know, I'm looking at this, and when I look at these problems, I'm often trying to visualize if there's any right-angle triangles we can make to help us solve the problem. And actually in this one there is. So if we take a minute to just draw a straight line down from point A, we can make two right-angle triangles. Triangle 1 over here and triangle 2 over here. And we've got quite a bit of information. We've got some angle information and we've got some side information. So what else can we add to this diagram? Well, first off, 208 degrees on the bearing to B, so that's from north all the way around. If that's 208 degrees, what's this angle in here? What's this angle A? Well, angle A is going to be equal to 208 minus 180, because this is the straight line here. So that's 180 degrees down to the straight line. And then whatever is left over is the extra angle A there. So angle A is equal to 25 degrees. So I know that I've got 25 degrees in that angle there. So let's use that. We've now got a little triangle for ourselves. Break it up. So I've said that this is 25 degrees. This is 48 kilometers. Let's figure out how long this length down here is. We'll call it D, a distance. And the reason I want to know this is because if I can figure out what this distance D is on the big picture, then I will be able to figure out what this distance here is. And then I'll have some information again that I can use to solve the problem. So I've got the opposite and the hypotenuse and an angle, so I'm going to use sine, and I'm looking for the opposite. So using looking for the opposite, cover that one up. That's sine of the angle times the hypotenuse. Remember, you need to feed sine something, so feed it 25 degrees times 48. And that means that our distance D is equal to 20.285 kilometers. Okay. So that tells us from here to here is 20.285 kilometers. So then what's my distance from here to here? That bottom part of the other triangle. Well, let's call that one E. We're going to find that E would be 64, the total length, minus 20.285. So what we find is that we've got 43.71 kilometers on the bottom part of this triangle. 43.71 kilometers. So we can now complete some of that part of that second triangle. So I'm going to draw him here, the triangle on the right hand side. So we've found that that's 43.71. We're looking for x. We're also looking for the bearing from north at point C to point A. So what other information do we have? One side is not enough to give us much. So let's go back to think about what we know from the other triangle. Could we maybe figure out what this length here is, this length y, the height of the triangle? Yes, we can. Y, what do we have? We've got angles and sides. This is going to be an adjacent. So we can use cosine if we want, or tangent, or even Pythagoras, because we know two sides of the triangle already. So what should we do? Let's use Pythagoras. Remember, we know that d down here is 20.285. We found that distance. So looking for a short side, we're going to have 48 squared minus 20.285 squared. And that is equal to 43.5 kilometers. And remember, if you wanted to, you could have used sine or cosine or tangent over here as well. So that distance, that height of the triangle, 43.5, is this one here. So that's also this edge here on this triangle. So 43.50 kilometers. Okay, now we know two sides. We've got 43.5 and 43.7. So we can find the hypotenuse there. So x is equal to, that happens to be the long side, so 43.71 squared plus 43.50 squared, square root, and that is equal to 61.2 kilometers. So that is going to be the length x here, 62.1 kilometers. That's part of the problem, the distance he must travel. Okay, and we need to know the bearing. So to figure out what the bearing is, we need to get some information here. If we take a look at this, what is something that we could solve that would be useful? What if we solve for that angle? Let's call it C. So for angle C, we have the adjacent side and the opposite side. So for angle C, we can use the tan inverse. We're going to use inverse because we're looking for the angle. And using tangent, we need to feed it opposite divided by adjacent. So use your brackets. 43.50 divided by 43.71 bracket. And we're going to end up solving that that is 44.9 degrees. Almost 45 degrees. So this angle in here is 44.9 degrees. So what can we do? Well, what's the distance, what's the angle, I should say, from north to here? That's 3/4 of a circle. So that's 270 degrees to start off with. So we're going to go with 270 plus 44.9. Because this angle here we know is 270, 3/4 of a circle, plus 44.9, and this is going to get us 314.9 degrees. And remember, bearings have to be in 3 digits only, so we'll round that to 315 degrees as our bearing. So again, 315 degrees from here all the way through to there. And you're done.